And we're now looking at example 7, 8, and 9 and expanding our logs using log properties. These are going to get a little bit more in-depth because we're going to use a few of our properties all in one. Again, there are different ways to do these, so you can do them in different orders. I'm going to choose one way. So on this very first problem, number 7, I'm going to take my 3 and I'm going to use the power property to rewrite this as a coefficient. So I'm multiplying 3 times log of AB cubed over c to the 5th. I can then split this up using the product property because we're multiplying a times b. So we'll split that up into 2 separate logs with addition. And then we're going to use the quotient property to split up our division of the c to the 5th. Okay, keep in mind though when we're splitting this we need to keep our 3 as our coefficient. So 3 log of a plus 3 log of b cubed, and then the division minus 3 log of c to the 5th. I fixed my 3 here. Okay, we're almost done. Notice each of our arguments only has one term, but we still have exponents. So we're going to use our power property again to rewrite our exponents as coefficients. So we're using our power property one more time. This very first log does not have an exponent, so we can keep that as 3 log a plus, here we have a coefficient of 3 and then our exponent of 3. The power property tells us we're multiplying, so 3 times 3 is 9. And then we have log of b minus, on our third one we'll do 3 times 5, which is 15 log of c. So our final is 3 times log of a plus 9 times log of b minus 15 times log of c. And again, if you did it in a different order, you could still end up with the same answer as long as you're using all of the properties correctly. For number 8, we have a square root. Now, none of our properties tell us anything that we can do with radicals, but we already know something about radicals. We know that they can be rewritten as rational exponents, and we do know what to do with exponents. So that's what we're going to do. We're going to rewrite this thing. But instead of having a square root, we're going to have an exponent of 1/2. Just be careful that you have a parentheses since the entire argument is under the square root. Everything is being raised to that 1/2 power. All right, now I'm going to go ahead and a different route, and I'm going to distribute the 1/2 just so you can see another way inside my parentheses. So we have log base 7 of a to the 5/2 times b to the 1/2. And that's just power property of exponents. And now we can split this up using our product property of logs. So we'll rewrite this as 2 separate logs. They will both be base 7, but we're going to split up our argument. So we have log base 7 of a to the 5/2 plus log base 7 of b to the 1/2. And finally, we'll use our power property to rewrite our exponents as coefficients. So we have 5/2 times log base 7 of a plus 1/2 log base 7 of b. Now I know I'm done expanding because I have single terms in my argument, and I do not have any exponents remaining. Let's look at our final example. Again, we have a rational exponent because a radical can be rewritten as a rational exponent, so we'll start there. Log of b squared times c divided by d to the fourth. Now this entire argument is being raised to the 1/5 power, since that everything in the argument is underneath that fifth root. Okay, I'm going to try this one by starting with my power property. So we have 1/5 times the log of b squared times c over d to the fourth. And then we can split this up using our product property and our quotient property. Remember, you have to keep the 1/5 for each log, so 1/5 log of b squared plus 1/5 log of c, and then we use the quotient minus 1/5 log of d to the power of 4. All right, we're almost done. Each argument only has a single term, but we can't have exponents, so we'll use that power property again and move our exponents to become coefficients. Remember, we're multiplying here, so we get 2/5 log of b plus 1/5 log of c minus 4/5 log of d. And my answer is complete.